Okay, ladies and gentlemen, this video is on the 45, 45, 90 triangle. Okay, so let's say we had a square. Well, what do we know about a square? We know every side in a square is exactly the same, right? They're congruent to each other. So again, let's say our square had dimensions of, let's say, 8 on each side. We won't worry about units this time. Okay? Well, again, what do we know about a square? All the sides are the same. We also know all the angles are 90 degrees, right? And that's what makes a square such a special, perfect shape, right? All sides the same, all angles a perfect 90 degrees. Well, one thing we may want to know about a square is the length of the diagonal across it, right? And using our common sense here, guys, what's going to happen when I draw that diagonal in there? It's going to split these corners, right? And therefore, each angle is going to be 45 degrees, right? 45 degrees. Okay? So, if you notice, we now have two 45, 90 degree angles, right? 45, 90 degree, triangles there. They're congruent triangles. They both have the same angles in them. They both have the same sides. And they both share that diagonal in the middle, correct? Okay. So let's just take a look at one of those diagonals. So I'll just take this diagonal, or this triangle out here. And again, we know that these are 45. We have a 90. We already know that these sides are 8. So if I want to find a diagonal, let's call it C, because that's usually what we call the hypotenuse. Let's see what we get with Pythagorean theorem. We'd get 8 squared plus 8 squared. Let me be a little bit neater there. 8 squared plus 8 squared equals C squared, right? Because A squared plus B squared equals C squared. Right? Okay. So that means we'll have 64 plus 64 equals C squared. We'll have 128 equals C squared. So to find C, I'm going to take the square root of C squared. So my answer is the square root of 128. But one thing you better get used to, guys, especially going into next year's math class, we got to always simplify those radicals. Even when it's not asked for, even when we're not told to do so, simplify the radical. Okay? So obviously I need more space here, but I'm going to just go ahead and put it right here. So if I have the square root of 128, I know I can go ahead and break it down. So that would be, for example, 2 times 64. 64 is 2 times 32. 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. Wow, a lot of 2's. And 4 is finally 2 times 2. And we're going to take pairs of them and make regular numbers out of them, right? So this one with this one makes a real 2. This one and this one makes another 2. This one and this one makes another 2. And finally we have one extra 2, which makes a square root of 2 still, right? And if I times those 3 2's together, I know it's 8 square roots of 2. So let's go back to our original problem here. So now I know this C right there is 8 square roots of 2. Now to save us a little time, guys, what I was just trying to show you is that there is a pattern with 45, 45, 90s. And here's the pattern. Follow the red here. I know, first of all, what's cool about a 45, 45 is both sides, both legs as we call them, are going to always be the same. Because remember, they're the sides of a square, right? And notice the diagonal also is 8 in this case, but it's 8 times the square root of 2. And that's all you need to know. The hypotenuse is always square root of 2 times bigger than its respective sides. Okay? And that's the information we're going to use as we solve a series of problems here. So you sort of already saw this one here, but hopefully you realize, hey, wait a minute. If that side is 5, what's this side over here got to be? Well, it's got to be 5, right? Because these are two sides of a square. Remember, two angles there are the same. That means those two sides are going to be the same, right? What about the x? Well, here we had 8 square root of 2. So here we have 5. What's this going to be? 5 times square root of 2. That's as simple as it gets, guys. Let's use that information one more time. Look at this one here. They already gave us. Notice the hypotenuse is 6 square root of 2. So what's the x side here got to be? Hopefully you came up with 6, right? And that means this side over here's got to be 6 because they got to be the same. Again, here's my two congruent angles. Therefore, I know these two sides are congruent, right? They're the sides of the square as we were shown before. Okay? But anyways, follow the purple. Again, let's see if this makes sense. If I have 6 here, our pattern says it had to be 6 square roots of 2. It's as simple as that. Okay? Let's try the next one. Now, this one's a little tougher, guys. So I'm going to share with you again a little trick. All right? Normally, would you agree that if one side is x, the other side over here's got to be x, right? And wouldn't this third side here be x times the square root of 2? Correct? Well, guess what? Can't we just put these two together and solve for x? Yeah, let's just go ahead and do that. I know that x times the square root of 2 equals 8. And to solve that, I'm going to divide both sides by square root of 2. And now I know x is going to be 8 over square root of 2. Now, going by the textbook, guys, we can't divide by a radical, right? So we're going to rationalize it. We're going to times by square root of 2 over square root of 2. And let's see what we get now. We're going to get 8 square root of 2. And square root of 2 over square root of 2 is simply square root of 4, which is 2. And now, can't we simplify that way? Because 8 divided by 2 is 4. So what I just figured out, guys, is my missing sides were both 4 square roots of 2. And I can check that real quick. Look, if I take 4 square roots of 2, I know if I times it by another square root of 2, I'm supposed to get back to the hypotenuse, right? And, of course, square root 2 is a 2, and 4 times 2 is 8. So, guys, with more practice, guys, you're going to be really good at these like I am. Let's try at least one more. So if you look at this one, oh my God, look at these radicals. I'm confused, right? No big deal. Because after all, we know that if those two sides are my legs, those are the sides of the square, right? We know they have to be the same, so that makes sense. So what about the hypotenuse? Don't we just simply take the square root of 6 times what? Square root of 2, right? And that, of course, is square root of 12. And guys, that's our answer. Let's make sure we simplify, though. 12 is 2 times 6. 6 is 2 times 3. Notice I have a pair of 2's, which will make that a 2, right? And that extra 3 is a square root of 3. And so the missing hypotenuse is 2 square root of 3. Okay, guys. Why don't we do just one more? Take a look at this one. Notice it's 45 here. We know that's 45 degrees, right? Let me make it a little bit neater. One more problem, guys. So here we have a 10. Now, what was the trick I showed you before? Well, let's label our sides like they traditionally are. This side would be x, and this side would have to be the same x, right? And the hypotenuse would have to be x times what again? Square root of 2. So I'm going to set that equal to each other because 10 is supposed to be x times square root of 2. Okay, so if x times square root of 2 equals 10, I'm going to go a little bit faster here. I'm going to divide by square root of 2 both sides. X is now 10 divided by square root of 2. Oh, we're dividing by a radical. Let's rationalize it. Let's times it by square root of 2 over square root of 2. So that's just simply 10 square root of 2. That right there is simply square root of 4, which is 2. 10 over 2 reduces to 5. So finally, I know the two missing sides are 5 times the square root of 2. Okay, guys. If I went too fast, I apologize. Please watch this video again. Pause it at the appropriate moments. Okay? But we got to know our 45, 45, 90. In a future video, I will explain one main reason why you ought to know your 45, 45, 90 and your 30, 60, 90s when it comes to trigonometry. Until then, bye.